Alright, today we are looking at section 8.5. It's all about area of parallelograms. So our objective is to find the area of parallelograms. You might be saying to yourself, like, we keep learning all these different area formulas. How am I ever going to keep them straight? Well, if you check our schedule on the board, we are making a note card later this week that you can put all these formulas on before the test. You can use the note card on the test. So if you're feeling like you're being overwhelmed by formulas, we will help sort them out for you later this week. Alright, so as you're writing these words down, I want you to draw a quick diagram. Remember that parallelograms have two sets of parallel sides. So this one is parallel to this one is parallel to this one. When we are talking about the base of a parallelogram, it's either pair of parallel sides. So really you could pick either set. I usually pick the one that it's sitting on as the base. And then you cannot use the other set of parallel sides as the height. Kind of similar to the idea with the triangle. The height is the perpendicular distance. So that would be the height. So the base is actually one of the sides of the parallelogram. Remember, the opposite sides are congruent. So you could use the top side, you could use the bottom side, you could use either one of the sides actually. Just pick one of the sides as the base, and then the height is perpendicular to that base. Again, very similar to the idea we did with the triangles. They have to form a right angle to be the height and the base. So here is our formula for today. It is the same as a rectangle. The only difference is with a rectangle we're actually using the side lengths for base and height. Remember here the height is actually not one of the side lengths. It's the perpendicular distance between the bases. Any questions on our formula for today? Base times height. Alright, here are the first two examples. Try to draw these, give it a shot. They might not be perfect, but they will be useful to have. If these were on the quiz, they would already be drawn for you, so you wouldn't have to worry about drawing them. Alright, so what is the base on number 1? 5. What is the height on number 1? 9. What is 5 times 9? 45. Very good. Raise your hand if you have any questions. Alright, example 2. What is the base?
17.
What is the height? Quiet, guys. What is 17 times 12? Anyone have it? 204. Thank you. We're talking about area, so you still want to put that squared on your units. Notice that if you put the height on the outside, it would be the same as if they drew it right here. So just be aware of that. Same thing. Any questions? Alright, pick one of these and put it in your notes. The other two you can just write the work, but pick one of the diagrams and try to draw it. I'll give you a minute. Alright, so we are still using that same formula from earlier. Area equals the base times the height. The only difference is now you're given the area and you're missing one of the other segments. So either you don't know the base or you don't know the height. So in example 3, the area is 63. So instead of A in your formula, just write the 63. Equals base. We don't know the base. And the height is 9. Yep. The way you get rid of multiplying by 9 is to divide by 9, and then B would be 7. Very good. We're talking about meters here. Seven. All right, same thing on number 4. We want to write an equation using that formula. So area equals base times height. The area is 144. The base is 16. We don't know the height. So we're going to divide both sides of this equation by 16. And you should be coming up with 9. Alright, and the final example for this slide, we're going to have 55 equals the base times the height. Remember, multiplication, the order doesn't matter. So if you want to put 5b or b times 5, it's the same thing. I'm just going along with the order of the formula. And then, yes, here b would be 11. Questions? Alright, so next we're looking at area of a rhombus. So remember, a rhombus is a type of parallelogram. So if you're given the base and the height, you can just use the formula we already talked about. However, usually I give you the information linked to the formula that I'm showing you. So in the next few examples, I will only give you information about the diagonals of a rhombus. So the area is 1/2 the diagonal times the diagonal. And if you're wondering, like, well, why does this work? If you think of this as a figure like that, the diagonals are the base and the height. So that would give you the area of this entire figure that I just drew. And then you can see that the rhombus is half of that. So that's where this formula comes from. But you can just memorize it. 1/2 diagonal 1 times diagonal 2 of a rhombus. Go ahead and draw these. We are using that formula we just learned. So area equals 1/2 one diagonal times the other diagonal. Now in example 6, do you see how you are given 14? That's this whole diagonal. And 8, that's this whole diagonal.
Did you say right there?
You need to draw these, yep. Does everyone see that though on example 6? You're given the length of the entire diagonal. So you're just going to use those two lengths and the 1/2. So area equals 1/2, 14 times 8. This is very similar to when you were typing it into your calculator for the triangle. You can do 0.5 times 14 times 8, or you can do 14 times 8 and then divide that answer by 2. You should be getting the same thing. You should be getting 56 square meters. Go ahead and check that in your calculator just to verify that you know how to type it in when you're actually doing this on your own. Any questions on that one? Now, does anyone see the problem we might run into on number 7?
Not really.
Do we know the entire length of each diagonal? Yeah, we have to add these. Like if I want this whole diagonal, I would have to add the 3 and the 3, which is easy. You can do it in your head. What's 3 plus 3? 6. Good. And then the other way, you would get 12. Make sure you're using the right numbers here. It takes a little bit of extra work, a little bit of extra thinking, but it's not too challenging. Anyone know what you get? Yeah, 36. Good. So again, this is when you're doing the area of a rhombus and you're given the diagonals. Any questions?